Hello everyone. Today we are doing Module 1, which is Thinking Critically. And so before we get into any of the problems, we're going to talk about what thinking critically really is. So, what is thinking critically? It is problem solving. So problem solving is something that where we change something into a different state. There has to be a change that's happening. And there are two types of problem solving. There is well-defined and ill-defined. Well-defined is a clear starting and ending point. So you know what you're going to start with and you know what you're going to end with. And then the ill-defined, it's a little bit less clear where your start or end point is, and that is for us to figure out. There are different ways to do this. There are algorithms, which is using patterns. There's trial and error and stuff like that. So, sorry, got something in my throat. So anyway, now that we know what problem solving is, we are going to move on with actually solving the problem. So first, we have a problem here that is a puzzle. So we're going to complete the puzzle, and we're going to use our problem solving skills to figure out how to solve this problem. So here we have these unknown variables right here, here, and here. So we're going to have to figure out how to get these. And so what I see here is that the sum of these two equals this. And that's what we're trying to find. So we can see that the opposite of addition is subtraction. So we're going to do 12 minus 7 to figure out what the variable is. So what is 12 minus 7? Well, it is 5. So let's test that out. 7 plus 5, does it equal 12? You can do it in your calculator or in your head. I'm not a very good mental math person, so sometimes I use my calculator, but that's totally fine because as long as we get the right answer, right? So now we see that that all adds up. And then now we're going to move on and we can do 15 minus 7. And that gives us 8. And then we gotta check to see, does 7 plus 8 equals 15? Yes, it does. So now we're left with one side left. So what we're gonna do is do the same thing, 20 minus 8. I already know that that is 12, but you can, again, draw it out, put it in your calculator. And now we see that all of this works. The sum of each bubble equals the middle number, and that's exactly what we were trying to find. So now it doesn't seem as hard, so we can move on and do some more. So here, it's always the easiest to start with the number that we are already given in the bubble. So I see here that there's a 6, and the number that we're supposed to add to it is going to equal that. So we can do 13 minus 6, which gives us 7. And so, does that work? 7 plus 6? Yes, it does. So we found that side. Next, we can move on to do 21 minus 6, and that is going to equal 15. And then we see that that adds up with 6 to get 21. So now we're only left with one more side. 19 minus 15 is 4. So 15 plus 4 is 19. And there's another correct puzzle that we've solved. And so here's another one. Okay, so we're going to see that we're going to start with this one because it's the easiest way to figure it out. So 6 minus 3 well, we're going to figure that out. 6 minus 3 is 3. 3 plus 3 equals 6. And now we can go this way. 8 minus 3 is 5. And 12 minus 3 is 9. 9, 10, 11, 12. 9. Wait a second. 9 plus 5 equals 14. So that looks like that one is not going to work. So I'm just going to say that that's not going to work because we see that this side checks out, this side checks out, and even this side checks out, but this one does not check out. And so for our final one, we're going to do the same thing. We see here that we have an 8. 18 minus 8, I already know in my head that that is 10. So here we go. We can do 16 minus 10 is 6. And now we're that much closer. So that just shows you that some of these are really easy to do in your head, and some of them aren't so easy. So now we do 7 minus 6, which is 1, and we know that 8 plus 1 equals 9. So that one is done. And now we're going to move on to something else. So this question says, sketch all possible figures that can be formed and calculate the perimeters of each. Which has the greatest perimeter? So basically, there are 9 squares here on each one. There's 9 squares here and 9 squares here. It's wanting to see how many ways we can show that with the boxes. So that's what we're going to do, is we're going to show all the different ways we can do 9 boxes. Okay, so I've drawn out all these boxes. This one's not as pretty, but so like we said, there's 9 here, there's 9 here, and if we count, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 here. 1, 2, 3, 4, 5, 6, 7, 8, 9 here. So we just showed that we can do 9 squares. And if you wanted to do more ways, you could just take one off of here and drop it below. You could move it all kinds of ways, but I'm not going to show all that because we can just tell that there are different ways to do it. And that's the whole point, is just it's wanting us to know that there is more than one way to achieve 9 boxes. So now it's asking about the perimeter. So how do we find the perimeter? Well, what we do is we take each side of these boxes and we count all the way around. So if we're going to count the perimeter for these, we're going to start here. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So the perimeter of these boxes around the boxes is 18. So now we're going to count this side and we're going to find out which one is greater between all of these. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The perimeter is 20. And I'm pretty sure it's going to be the same here. Yeah. Let's see. Yeah, 20. So the greatest would be doing it this way. If we're trying to find the greatest perimeter, that's what it would be. Okay, so we're going to use this to solve the next few parts of this problem. So when we're looking at this, it looks a little complicated to me, to be honest, but all we're trying to do is find a pattern. So the way that we do that is by looking and seeing what we've got. So here it starts out with 1, 3, 6, 10. And I can tell here that they're adding 3 here. They're adding 3 here. And well, 6, 7, 8, 9, 10. They're adding 4 there. But then here we go. They're adding 4. And then it goes 4, 5, 7. So basically, we're just trying to find a pattern. Again, like these look super confusing, but the whole point of this is finding a pattern. So consider a new sequence of dot patterns. So here we're going to look at the pattern, and I'm going to change my color so it doesn't mess you up. So there's a bunch of things going on here. But what I'm really seeing out of all these dot patterns is, even though we're starting with 2 and then, all the dots are building on, if we look at it in a diagonal way, we see that they're going 1, 2, 3, 4. So what they're really doing is they're showing us that there's a upward pattern when we're making this shape. So in order to draw the next ones, we can just keep going. So we went 1, 2, 3, 4. Then we're going to go 1, 2, 3, 4, 5 here. 1, 2, 3, 4, 5, 6 here. And then it just keeps going. So now what we're going to do is, what we're doing here is we're finding, again, the pattern. So at the very beginning of that problem where we saw this, we can see that we're trying to find the sequence here. So what we're going to do for that is we're going to do 1 plus 4 equals 5, and then 1 plus 4 plus 7 equals 12, and then 1 plus 4 plus 7 plus 10 equals 22, and then 1 plus 4 plus 7 plus 10 plus 13 equals 35. So that shows us that the sequence is all right here. So we're going to go 5, 12, 22, 13, and so on. As you can see, we got the 35. And that's all that is to it. So now it's asking us to add 4 equations to this list in this sequence. So what we're going to do for that is we're going to just keep up adding 3 each time. So we've already started out with the 10. So next we're going to keep up doing what we did in the previous slide with these equations. So we can just keep adding 3 to this. So plus 7 plus 10, and then plus 13, that's the one we just got last in the last slide. And then plus 10, and this time we're going to do 13, plus 16 equals 51. And then I'm not going to write all these again, but basically after this you're going to add plus 19, which would give you 70. And then you're going to do plus 22, which would give you 92. So again, I've said it so many times, I'm going to keep saying it again. This is just looking for a pattern. And once we see that pattern of adding something or doing whatever, we just continue that pattern, and this is how we get all these numbers. So we can see that's how we do that. And so next it says observe that each pentagon number in the sum of an arithmetic progression compute the 10th term. So what we're going to do is find the 10th term by, we are going to just do what we were doing before, and we're going to look at that pattern. So 1, I should make that a little bit bigger, huh? Well, I guess it's not going to be getting bigger. Okay, let's start over. Make this a little bit neater for you. Okay, so we're going to do 1 plus 4 plus 7 plus 10 plus 13 plus 16 plus 19 plus 22 plus 25 plus 28. So we've added 3 this many times. So what we're going to do is going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that is our 10th term. So see, all we got to do is keep adding 3. That is the key here. So now we're going to show the formula for the pentagonal numbers and calculate the nth term, 9th, 10th, nth term. Well, as we can see, the 9th term would be 25 because we already found the 10th term. So just to do the nth term, all you got to do is do that. But if you're going to talk about the formula, what we do is 3n squared minus n over 2. Or you could do it another way where you do n 3n minus 1 over 2. But either one works. Okay, now what we're going to do here is we're going to find these unknown numbers here in this pyramid. So how do we do that? Well, first off, we start by, we know that these 2 would have to equal this box. Same thing here, these 2 equal this box. So we can do an equation, and we start off doing x plus 7, and then 7 plus 3 equals 25. Now we are going to, now that I'm looking at this, actually after I wrote that equation, I just had a thought. So we don't know what x is plus 7, but I know that 7 plus 3 is already 10. So what I can do is I can rewrite it another way. And I can do x plus 7 plus 10 equals 25. So now all I have to do is solve this. So I know that 10 plus 7 is 17. So we're going to set that equal to 25. That cancels itself out. X equals 8. So what we're going to do is we're not going to say that 8 is the answer because we can tell that that's not going to work. So what we're going to do is we're going to plug it back in to the formula. So we're going to put it in for x. So 8 plus 7 is 15. So that gives us our number. So see, it all works out now. And all we had to do was create an equation. Okay, next up, we have another one. So I know that 1 and y have to equal this. Y and 2 have to equal this. And so again, I'm going to make another equation. I'm gonna do y plus 1, and then y plus 2, and I'm going to break this down, distribute 2y plus 3, 2 and 1 equal 3, equals 15, which is this number right here. And now we're gonna try to solve this. So minus 3, that cancels out, minus 3, 2y equals 12. Divide, that cancels out. And 12 divided by 2 equals 6. So we know what y is now. We just solved for y. So now that we know what y is, we can figure this out. So 6 plus 2 is 8. 6 plus 1 is 7. 7 plus 8 equals 15. So that's an easy way to set an equation to figure that one out. And for the very last one we have to do on this PowerPoint, I decided to put an actual pyramid because I just started thinking about the pyramids in Egypt once I saw this. So next, we're gonna just do our very last one here. So again, we're gonna create an equation. And for that equation, what we're gonna do is we're going to just call this x because we don't know that. And if we can find this, then it will help us find this a little bit easier. So 2 plus x equals z. So 2 plus x is going to equal this, remember? The bottom two are going to equal the middle ones. So now we do x equals z minus 2. Z minus 2 plus 9 equals y. 2 plus 7, that would be equal y. So now z plus 7 equals 27. So we got 2z plus 7 equals 27. So 27, we get z equals 10. So now that we know that this equals 10, what plus 2 equals 10? So we know that that would have to be an 8. 8, 9, 10. So 9 plus 8 would be 17. So now that we see that z equals 10, we figure that out over here, and we know that 2 and something had to equal 10. Well, I already know in my head that that's 8. And if you don't know that, then you can just do 10 minus 8 to figure out the 2. So now we just solved our last pyramid. Okay. So now this one seems a little tricky, but really it's not that hard. So what we know is that it says 4 married couples belong to a bridge club. The wives' name are Kitty, Sarah, Josie, and Ann. Their husband's name, in the correct order, would be David, Will, Gus, and Floyd. Okay. So, whoops. what we're going to do here is, I don't know what just happened. I accidentally clicked something. But we're just going to move along. And so we have to really pay attention to this. So we read that Floyd is Josie's brother. Floyd is Josie's brother. So we know that Josie, we know that Josie is not married to Floyd. Based off reading this, we know that she's not married to Floyd. And now Josie and Gus, it says that Josie and Gus dated some, but then Gus met his present wife. So that would mean that Josie and Gus are not married. So we can take him out. And then it says Kitty is married to Will. So we know that. And we know that. So now we know that Floyd is Josie's brother and that he would have to be married to Anne again. And now we know that Sarah is married to Will. And now that Will is married to Sarah, as I said, there's a lot of names that's kind of hard to get, but the key is that we just want to get it. And we know that Gus married to Josie. And I just realized that I need to put this here. And okay. So we know that Kitty is married to Will. And that Floyd is Josie's brother. So this is how it all works out. It's a little confusing, but it just takes some sitting down and figuring it out. Okay, moving on. Consider that trapezoidal numbers 1 plus 1 plus 1 plus 2. So see, we're trying to find a pattern here. Create a dot pattern to represent trapezoidal numbers. So in order to do that, what we're going to have to do is to create a dot pattern. So we look here and we see that, oh, here it goes. I did not see that up there. There we go. 1 plus 1 plus 1. So that really just means 1 3 times. So we know that that would have to mean 1, 2, 3. So that's 3 dots. That would be 3 dots because we know that this equals 3. And so here we're just going to add them up. 2 plus 2 plus 2 plus 1. So 1 plus 2 plus 2 plus 2 plus 1. That equals 8. So that means we need 8 dots. 1, 2, 3, 4, 5, 6, 7, 8. Not the best trapezoid, but it'll do. Okay. So now we're going to look again at the next one. 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1. And what does that give us? Well, it gives us 15. So I'm not gonna try to make y'all go see this really slow. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. I know these should be dots, but if I do dots, they're gonna be too small. So should be a little bit more. Anyway, and that's just gonna keep going, so on and so on. So we're seeing the pattern here, and that is going to be 3, 8, 15. And so what we're going to do next is, oh yeah, okay, now it says, notice that these, I'm not going to say that out loud, show how the dots in the representation of a trapezoid number can be rearranged into a rectangle. So all we have to do now is just, for the rectangle, is we show 1 times 1, and that 2, 3. These would be the one, 2, 3, 4, and then we would have 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15. Okay, I'm sorry, these are not perfect. But anyway, what I'm writing right here means is that there's going to be 3 columns and 5 rows. 2 columns and yeah, 4 across, yes. 1 and 1. So now that is all I have for y'all today. I know some of these were a little bit challenging, probably for myself and you, but basically what we're trying to achieve here, again, is problem solving and why that's important, and how we can apply problem solving to math. We problem solve every day, but this is just showing us how we can apply it to math. And if you'll notice, pretty much all of these problems, we had to find a pattern. And finding a pattern will help us figure out what the pattern is going to look like, not just in the beginning, but way down the line, what's the pattern going to look like. So that's really the lesson here, and I will see y'all guys next time. Thanks for watching.